Okay, let's evaluate this limit. So you'll notice that we have our y values approaching a constant 4. So I'm not going to argue that there are a couple different directions we could go with this. You may think about first starting out with our y squared minus 1 up in the numerator. That's the difference of squares, and we could begin there by going ahead and reducing that down, right? Doing a little bit of factoring. I noticed that we have a y minus 1 cubed, meaning 3 copies of y minus 1 in the denominator. We could start with that, but what I'm going to go ahead and suggest is we go ahead, as we do with all of these, and go ahead and try to evaluate your function at that given value of y, what you're approaching. So that's going to be 7 times 4 is going to replace the y, minus 4 squared minus 1 up in our numerator. And then we have 3 times 4 squared times 4 minus 1 cubed in our denominator. Then think about, how do we simplify that down? Well, we have 7 times 16 minus 1, doing that square first. Then we have 3 times 16, 4 squared, multiplied by 3 cubed. Okay, well, that'll reduce a little bit further. Let's go ahead and think 7 times 16 minus 1 will make 15. And then in our denominator, we still have 3 times 16 times 3 cubed is going to make 27. All right, we could multiply this out, get quite large numbers, and the result will be some fairly large numbers. But first, I'm going to think of that 15 as 3 times 5. We could factor it and replace it with 3 times 5. And why I'd want to do that is because I notice we have a 3 as a multiple in our denominator. So 3 over 3 makes 1. We can reduce this number down. Then we're just left with a little bit smaller calculation in our numerator, where we have 7 times 5 remaining, which will be 35. Now the denominator is going to be large numbers, but I know 16 wasn't a multiple of 7, neither is 27, and neither of those is a multiple of 5 either, so we really just have to multiply 16 times 27, which works out to be 432. All right, because we didn't end up with 0 over 0, or 0 divided by some number, or some number divided by 0, that's it. We're done. We already reduced it as much as possible, so that's our solution. Hope this helps. Always, when you're doing limits as your variable's approaching a number, make sure to try to evaluate them by substituting that value in for your variable first.